Well, hello guys, here Mr. G with another video. This time is going to be question 9 from the Eastern Cape question paper done in September 2023. Is the last question of this paper. I'll leave the question in the description below so you can answer the question before watching the video. But before, don't forget to subscribe for the channel. The question says the electrolytic cell shown below is used to the electrolysis of copper 2 chloride solution. Okay? A and B are carbon rods. So you can see that this one is an electrolytic cell. B is connected to the positive side of the battery. Remember, this one is a positive side, this one small is a negative side here. In the electrolytic cell, you need to remember that the one connected to the positive side will be the anode, so B is anode, this one is always like that, and the one that is connected to the negative side is the cathode. So that is what you need to remember first of all. This is the cathode because it's connected to the negative side. This one is the anode because it is connected to the positive side. What else? At the anode, oxidation take place in both galvanic as well as electrolytic. In the cathode, reduction take place. Reduction take place at the cathode. Okay, that is important to remember from the previous, from this topic. So define electrolysis. And you can say that this is a chemical process in which electrical energy is converted to chemical energy. And that will give you 2 easy marks. Is this process of electrolysis exothermic or endothermic, guys? We need to supply energy. Energy have to be supplied. Therefore, this one is energy. Let's write here energy. So for this one to happen, energy is given. It's given to the system. Therefore, the reaction is endothermic. It needs energy to work. So this one is endothermic. And if you say endothermic, you will get 1 mark. So far, so good, quite simple. Write down the half reaction that occur at B. Now B is the anode is oxidation, and now we are working with copper chloride. In other words, we are breaking copper chloride here. And let me show you something in terms of copper chloride. This copper chloride is copper 2 chloride, because of the 2 there you can see it's copper 2. So it's CuCl2. This one is going to be broken into Cu2 plus and Cl minus, and we'll have 2 of that there. We're going to come back here, we will need this one here. So you can see that these ions are going to be broken within the substance there. Okay, now what is important to know there? Here the copper is positively charged, the chlorine is negatively charged. If you come back to the electrode, we have that this the anode is oxidation taking place, and this one is positive electrode. If you go to the anode, this one is a negative electrode there. So in this electrode here, the chlorine will be oxidized. So here is oxidation. In this case, chlorine Cl minus will be oxidized there. That's quite simple, guys. Very easy. Let's go to our table and look for chlorine here. So we're looking for chlorine. Now in this case, we're not going to be drawing a C, because this one does not work for the electrolytic cell, but we are looking for the reactions. So we're looking for chlorine. Let me find it. There it is, chlorine. Here is chlorine. Let me show you. Here is chlorine. This one is what we are looking. Now what is happening to chlorine? It's oxidation. So you need to know that this oxidation, because it is at the anode, is oxidation, and oxidation you are going to write it from right to left, so you're going to write it in that direction. That is what happened. On the other one, we're looking for copper 2. Copper 2 is here. If you would have to write copper, you will write it from left to right. You know what, let's write both of them here, even though it is the question is only for oxidation. So for chlorine, if you write it there from the table, you will have 2 Cl minus, and I'm writing exactly as it is in the table. The only difference is I'm using only 1 arrow. Cl minus is a 2 Cl minus, sorry, 1 arrow. On the other side I have Cl2 gas, The states, you know what, let's not write the states, it's not needed the states there. Plus 2 electrons. This one is the oxidation half reaction for the electrolysis of copper to chloride. Quite simple. If you do that, you'll get 2 marks. Now, for the reduction, let's write down the half cell for the reaction, the half reaction for the reduction half cell, or let's say for the cathode. Now that one is for copper, Cu2 plus, is copper 2. So in this case, what are we going to write? From left to right in the table, from left to right, I'm looking for it in the table in front of me, there we go, is Cu2 plus electrons will give you Cu plus, no, sorry, here 2 electrons. 2 electrons will give you Cu. This one is what happened in the cathode. So here is the 2 half cell, but the question is only for the oxidation. Write down the half cell that okay, electrode B. Electrode B is the anode, and therefore oxidation take place, and in this case is chlorine. So there is everything. Quite simple. Now write down the 0.369 gram of copper is deposited into the cathode in 27 minutes. Now it means that copper were deposited there. How much copper was deposited there? 0.369 grams of copper were there. Cu. Okay? In 27 minutes, the time was 27 minutes. Calculate the electrical current used during this process. This is a very good question, and it used to be the often in this question. So let's start from the beginning. We're looking for electrical current. This is paper 1's formula. Electrical current is equal to the rate of flow of charge. So it's Q divided by time. This is what they actually want you to calculate. Now from here, what we don't have the charge. So we have to calculate that charge first. How can we calculate charge? We have to go all the way back to grade 11 electrostatic. Alright? In the part where we say that charge is equal to the number of electrons multiplied by the charge of electrons here. But we still don't know the number of electrons, so we're moving on. We're moving on because we have a lot of unknown. How do we get the number of electrons? Well, you need to know that the number of mole is equal to number of particles divided by the Avogadro's number. This one is also done in grade 10. This here, guys, is the number of electrons. That one is the number of electrons, which is the same. You know what? Let's do this one. Don't you get confused? This one here is the number of electrons. Number of electrons. But now we still have more problems. We do not have the number of mole of electrons. In other words, this one here is number of moles. Let's write it here. Number of moles of electrons. Number of mole of electron, and there is what begins. Now where do we calculate number of mole? Number of mole is equal to mass divided by molar mass. The mass is given to us as 0.369. The molar mass of copper, we're working with copper. You go to the periodic table and you'll find that is 63.5. So saying this one, you will get the number of mole of electrons. Remember, this is number of mole of electrons. No, let's fix this one. This one is not the number of mole of electrons. This is the number of mole of copper ion. This is the number of mole of copper. We're going to go back there. This is number of mole of moles of copper. Let's write Cu. Right? This is the number of mole of copper. I'll show you just now where we are going. Okay? So now from here, this one will give you 5.81 times 10 to the minus 3 mole. This one is for copper, for Cu. Alright? But we go back here to the half cell we have. We're going to rewrite it on this side here. Okay, we have that Cu, let's write it as it is, the Cu2 plus 2 electrons is going to give you Cu. So here we are. Now, why we need this one? Remember, we need the number of mole of electrons to move all the way back to the Avogadro's number, and we can have the charge, all right? So this one is used because we need the ratio between Cu, or electrons, let's write here, ratio between the electrons and the copper, and the ratio is 2:1. Alright, it means from here we can get that the number of mole of electrons will be equal to 2 multiplied by 5,81 times 10 to the minus 3. Alright, there we go. This one will give you the number of mole of electrons. That will be the number of mole of electrons. And this will give you 1,16 times 10 to the minus 2. I convert everything to a scientific notation because the numbers are quite small. This one here is the number of mole of electrons. Right? This is the number of mole of electrons, and this is what we are going to substitute in there, because now we know the number of mole of electrons. We need to know the number of electrons now. So we're moving all the way to that formula. Number of mole is equal to number of particles divided by Avogadro's number. Right? We substitute. This one will be equal to 1,16 equal to number of particles divided by Avogadro's number is given to you is 6,02 times 10 to the 23, and there you will get now the number of electrons. So the number of particles, which is number of electrons in this case. Okay guys, here is a mistake with the substitution. It's 1,6 times 10 to the minus 2, all right, equal to number of particles, which divided by 6,02 times 10 to the 23, right? And this will give you 7 times 10 to the 21. Now this one is electrons. This is the number of electrons that were transferred during that specific process. With this number of electrons, now we are going to calculate the charge. So we go from here to the charge, as you can see there. So let's go to charge. Charge is equal to the number of electrons multiplied by charge of 1 electron. All right, we go in there. When we substitute here, we have that is 7 times 10 to the 21 multiplied by the charge of 1 electron, which is 1,6 times 10 to the minus 19. So you get that the charge is equal to 1,12 times 10 to the 3. All right, coulombs. And from here we go into the current, which is the final part of this question. So from here we go into current. Current is charge divided by time. The charge is 1,12 times 10 to the 3 divided by the time. The time is given to us 27 minutes. We cannot work in minutes, we have to convert to seconds. So it's 27 times 60, because 1 minute have 60 seconds, and then you will get the final answer, the current to be 0,69 amperes, and this is the question. I hope it helped. It's not that bad. It's not that bad. Now, marking wise, where are the marks? One of them is for calculating the number of mole of copper. There is 1 mark for that one. 1 mark for multiplying by 2 to know this part of the ratio between the electrons and the copper. There is 1 mark for calculating the number of electrons. There is 1 mark for calculating the charge. There is 1 mark for the formula of electric current here, because it's what you're actually looking for. There's 1 mark for the substitution and 1 mark for the final answer. There's a lot of mark, but it's not that difficult to get. Guys, I hope it helped. This is a very good question to practice for the exams. A thumb up, subscribe for the channel if you didn't. I'll see you next time. Mr. G here.